two fundamental types of air pressure systems. Low pressure, can you guess what the next one is? And high pressure. Now, of course, there are more technical scientific names for these two things. I generally refer to them as low pressure and high pressure. Those are perfectly fine names, but there are technical scientific names. You need to know those. Here's what they are. First, a cyclone or a cyclonic system. Now, this is a little bit of a bummer name just because of this. In the Western Hemisphere, the biggest storm that exists on this planet is referred to as a hurricane. However, in Asia, that same type of storm goes by the name typhoon, but it can also be called a cyclone. The problem with that is that it's a bit of a misnomer, because while every hurricane is indeed a cyclone, every cyclone is not a hurricane. But I'm not going to make them change that, so we have to live with that fact. A cyclone is this. It's a region or center of low atmospheric pressure, also known as a low. So in other words, this is low pressure. In the northern hemisphere, the air converges, which means it comes together, it rises, you know what that means, and it circulates in a counterclockwise direction. Low pressure systems, see, I'm going to generally refer to it as low pressure, cyclonic systems are associated with clouds and precipitation. Keep in mind there are three movements. This is critical that you keep the movements in mind. Converging, rising, and circulating air. Let's take a look. I built this little diagram for you. This is a side view. Imagine that you're looking out across the landscape and you can see the movement of the air. Of course you cannot, but if you could see the movement of the air, the red arrows are representing the movement of the air in a low pressure system, which is the air is going to converge and rise. When you have converging, rising air, this is what creates a low pressure system. Well, it may not be the thing that creates it, but this is the result of it. Now, if you look, you can see that indeed there are clouds forming because low pressure systems, cyclonic systems, are associated with clouds. And notice there are three movements. So far we have two of them. We have the converging and rising characteristics of low pressure. But there is a third movement, which is circulation. If you are up in space watching a low pressure system move in the northern hemisphere, the circulation would look like this, which is counterclockwise and in. Notice as you're looking at those arrowheads, the arrowheads are pointing towards the low. So it's not just making a circle around the low, it's counterclockwise and spiraling inwards. Okay, so converging, rising, circulating. Good. Of course, I did say the northern hemisphere. What changes in the southern hemisphere? Well, there are three movements, right? There's converging, rising, and circulating. Converging and rising are always part of low pressure systems, cyclonic systems. So there's never going to be a moment that converging and rising air are not part of low pressure systems. What changes in the southern hemisphere is circulation. In the southern hemisphere, the air circulates clockwise and in. Make sure you know those things. Make sure you know converging, rising is always part of a low pressure or cyclonic system. But that the circulation changes. It's always going to go inwards with low pressure, but in the northern hemisphere, that will be counterclockwise and inwards, and in the southern hemisphere, that will be clockwise and inwards. The second type of system is called an anticyclone or anticyclonic system. This is a region or center of high atmospheric pressure, also known as a high. In the northern hemisphere, the air descends, which means it subsides, it comes down, diverges, which means it pulls away from the center, and it circulates in a clockwise direction. High pressure systems, anticyclonic systems, anticyclone, high pressure are synonyms, are associated with clear skies and dry air. Again, keep in mind there's three movements: descending, diverging, and circulating. Take a look at this diagram. Again, you're looking across the surface of the planet. And as you look across the surface of the planet, if you were able to see the movement of the air represented by the red arrows, what you would see would be the air would be descending from aloft, and as it came down towards the surface of the planet, the air would be diverging, exactly what you see there. That is a hallmark of high pressure. And, of course, high pressure is associated with clear skies. You can see the sun there. But notice we only have two of the movements so far, descending and diverging. The third one is circulation. Again, if you were up in space and you were somehow able to see the movement of the air around a high pressure system, what you would see would be this. The air would be circulating in the northern hemisphere, clockwise and out. Now look at those arrowheads. They are not pointing back at the high. They are pointing away from the high. So the movement in the northern hemisphere is going to be clockwise and out. Well then, what changes in the southern hemisphere? I bet you could probably guess. Remember, there's three movements: descending, diverging, and circulating. Descending and diverging are always part of high pressure. Clear skies, dry air, always part of high pressure. So what changes? Circulation changes. In the southern hemisphere, the air circulates counterclockwise and out. Still going out, but in the northern hemisphere, it's clockwise and out, and in the southern hemisphere, it's going to be counterclockwise and out.